Hello and welcome to the Maryland University of Integrative Health's Professional and Continuing Education course, Nutrition for Cancer Prevention Masterclass. I'm your presenter, Jason Bosley-Smith, clinical nutritionist and adjunct faculty member in the Integrative Sciences and Nutrition departments at MUIH. Today will be Lesson 1 of our 3-lesson series in Nutrition for Cancer Prevention. We'll start today with Lesson 1, Cancer Incidence and General Nutrition Recommendations. So a quote by Benjamin Franklin at the start, an ounce of prevention is worth a pound of cure. So the focus and goal around this particular masterclass is educating patients on optimal eating and nutritional considerations for cancer prevention or chemo prevention. What are the specific dietary patterns? What are the specific types of individual nutrients, herbs, and what are the general recommendations that are evidence-based from the scientific literature that link to some form of risk reduction related to cancer and cancer incidence. So a little bit of background on the statistics and epidemiology around cancer. So some cancer projections from the American Cancer Society that worldwide cancer cases are projected to increase by 50% between the time period of 2012 to 2030, upwards of 21 million worldwide cancer cases, with worldwide cancer death projected to increase by up to 60% from an 8 million to a 13 million count from that 2012 to 2030 period. So clearly an area for intervention. What can we do to reduce risk? What can we do from a patient perspective to prevent the incidence of cancer to begin with? Because once a patient has gone through the cancering process, even more challenging, even more complex with respect to nutritional care and intervention then. So, acting proactively, looking at it from a prophylactic standpoint, what are the dietary inputs that are going to be relevant to cancer risk reduction? And we'll really discuss the difference between primary prevention and prevention of recurrence, or what we would really call secondary or even tertiary prevention. So primary prevention would be that prevention from any type of initial incidence in the first place, preventing an individual from acquiring cancer. And of course, cancer is a complex condition and disease process. So there's multiple variables at play here. Certainly elements around sleep, stress, physical activity all come into play. But for our purposes, we'll talk primarily about nutrition and dietary inputs. And then prevention of recurrence, which would really be secondary prevention. There could be a situation you're working with a patient where they are actually a survivor and they're coming into your office to speak with you about, well, what are the types of dietary patterns and foods that I should begin to eat and incorporate into my daily diet that will prevent a recurrence, that will prevent the cancer that they had or secondary cancer incidence from occurring as well. So that's really our focus, is that it's not just prevention from a patient. It's not just prevention from a patient acquiring cancer in the first place. That's certainly part of what we'll discuss today. But also keep in mind the concept and putting into the context of a patient that has actually already had and recovered from cancer and is a survivor and is looking to have a secondary prevention, preventing recurrence of that cancer process, and how they optimize their physiology and metabolic health to prevent some form of recurrence of cancer. So I thought it would be beneficial to kind of start by taking a bit of a step back and looking at the hallmarks of cancer. So this is adapted from a paper in Cell that was published a few years back. And it really looks at the hallmarks of cancer. What are the characteristics associated with cancer as a disease process? What are the changes in biology, physiology, cellular mechanisms at play that are relevant to cancer? And then what we'll do towards the end of Lesson 3 is look back at all these variety of different nutritional implications and interventions that may affect each of these various hallmarks of cancer. So I'll just go through and read the list, and we'll kind of touch on a few of these to begin with. So we'll begin to see how there is clearly some dramatic change. And then, again, broadly, by definition, cancer is essentially that process of the cells going rogue, of having cells that become deregulated in a number of aspects, and having a lot of these features and hallmarks appear as part of the cellular processes that then become, more widespread through a variety of either sort of local cancer process that starts with a series of cells that certainly becomes an outgrowth into the tissue area, and then of course if something like metastatic disease comes into play, then we're talking about cancer cells that are proliferating through various tissues and various regions of the body. So we'll go through these hallmarks of cancer. So the hallmarks of cancer, including the evasion of growth suppressors, so tumor suppressors being kind of downregulated or turned off, avoiding immune destruction, so cancer being able to evade or hide from essentially the sort of our innate immune capacity and our typical immune protection, enabling replicative immortality, so the ability for these cancer cells to essentially become immortal and having, avoiding some of the normal processes that would result in an appropriate or programmed cell death, so evading things like apoptosis. Tumor promoting inflammation, so it's not just the actual cancer cells themselves, but what happens in the tumor microenvironment, how there is this tumor promotion of various cytokines and inflammatory mediators that become apparent in the surrounding areas of an actual tumor, in the surrounding cell and tissue space. Activating invasion and metastasis, so actually invading adjacent tissues, eventually the ability to break off and have cancer cells metastasize to various other tissues using either lymphatic vessels or a vascular system to travel to other areas of the body that can be local, regional, or really can be even further away from the originating area of the cancer. Inducing angiogenesis, of course, the growth of new blood vessels, so new vasculature developing, so cancer cells being able to induce that angiogenesis, which really supports their metabolic growth and their ability to replicate by bringing in additional blood flow, oxygen, and various nutrients to the cancer cells, so inducing that process of angiogenesis. Genomic or genome instability and mutation, so the concept of having these, again, the concepts around multiple hit theory, and the idea where you have multiple successive damaging events to the actual DNA and characteristics around mutation. Then once we have a mutation, then we again have a cell that's not operating under normal control mechanisms of the cell cycle. Resisting cell death, kind of going back to that idea of immortality and resisting appropriate cell death of apoptosis when a cell has become damaged and is really deregulated or is dysfunctional in some respects, resisting that cell death, which would normally be appropriate for a healthy, normal cell to undergo. And then deregulating cellular energetics, and we'll talk certainly a good bit about that. The idea of shifting cellular energetics and things like the Warburg effect, where the cancer cells upregulate the glycolytic pathways and start to drive additional glucose for proliferation. And then finally, sustaining proliferative signaling. So all these hallmarks of cancer, really important areas to potentially target, and are all being certainly investigated with a variety of different therapeutics and interventions. And of course, conventional therapies and treatments are typically targeting one or more of these at a time. But we'll take a step back and say, what does the evidence show us with respect to nutrition? What nutritional interventions may actually address some of these various hallmarks of cancer? So our learning objective for this lesson 1 is to explore the evidence-based dietary approaches associated with reduced risk of cancer. And again, we're looking at general recommendations in nutrition for cancer prevention. So this is kind of a broad overview, and we'll go into the details on each of these that you see with the icons on your screen, these evidence-based dietary approaches, which are cumulative through a body of research that's been, again, studied and acquired over a series of research studies and clinical trials, as well as epidemiology over the course of several years and decades. So some of the things that we know are certainly associated with a reduced risk of cancer incidence are an increased consumption of vegetables and fruits, increased consumption or adequate dietary fiber, certainly adequate at what would be the the RDA, but certainly above is useful as well. And then on the other side of that, what areas around sort of decreasing the diet? So decreasing things like excess amounts of processed meats, limiting sugar-sweetened drinks and reducing overall glycemic load, and avoiding excess alcohol. So generally the recommendations that have some evidence basis to them, and we'll go into each of those now and show some of the supporting evidence. So to begin with, increased consumption of fruits and vegetables. So a lot of this information is derived from, again, a variety of resources and references from specific large cohort studies and trials. So here, increased consumption of fruits and vegetables. There's going through some of the detail. Limited evidence consumption of non-starchy vegetables decreases the risk of developing cancers of the mouth, pharynx, larynx, nasopharynx, esophagus, lung, colorectal region, breast, especially estrogen receptor negative, and bladder. And then limited evidence of consumption of fruit decreasing the risk of a number of these same types of cancers. So both of these, and we'll go into maybe some specifics where we'll start to link some things together. Why would it be? What are the mechanisms potentially at play here? And we'll discuss it as we kind of make our way through, because I think we'll see some consistency among these different areas of where the evidence shows, again, from a broader, large cohort study, perspective or retrospective studies, and epidemiological evidence, and what mechanisms might be at play here. Certainly we have a good sense that in a higher intake of fruits and vegetable matter, these plant-based foods, is associated with the decreased incidence or risk for cancer. A number of different types of cancer is evidenced here. So with this dietary recommendation here, the association of this pattern and the direction of the effect are both consistent. Overall, the evidence is more persuasive of a protective effect. So I mentioned limited evidence consumption of fruits and vegetables, but that regardless of that sort of limited evidence, there is evidence that is persuasive of not only sort of an association here, but really a protective effect overall of an increased consumption of these types of foods dietarily. And a couple of examples of studies. So in the Nurses' Health Study, both 1 and 2, women who ate more than 5.5 servings of fruits and vegetables each day had an 11% lower risk of breast cancer than those who ate 2.5 or fewer servings. So already you can see, really by not even quite doubling the intake of fruits and vegetables, we have a reduced risk of cancer from these. And of course, looking back at what it constitutes a serving, defined as 1 cup of raw leafy vegetables, half a cup of raw or cooked vegetables, or half a cup of chopped or cooked fruits. So just to give some definition to share with patients, to get some specificity around what is it actually that we're talking about. And really, again, mechanistically, what are some of these mechanisms here? There's certainly a number of vitamins, antioxidants, polyphenols we'll talk about in another lesson, fiber content, which we'll talk about in a few slides here. All these areas may be the mechanisms that sort of underlie the reasons why the increased consumption of these fruits and vegetables have this association of a protective effect. Dietary fiber intake. So I mentioned the second recommendation generally as an evidence-based dietary approach for risk reduction of cancer and cancer prevention is adequate daily fiber intake, which is associated with a reduction in risk for colorectal cancer and in some studies, all cancer mortality. So an important component here, because this is certainly specific to the gastrointestinal tract and GI-associated cancers, but also there is some evidence that all cancer mortality is reduced with adequate dietary fiber intake. So for that specific metric and that statistic, it's really approximately 30.4 grams a day as associated with that decrease in all cancer mortality. The reduction in all cancer mortality was a 14% reduction with that 30.5 roughly grams. And with a dose response meta-analyses, they also indicated in that meta-analyses that a 10 gram a day increment in dietary fiber intake was inversely associated with a reduction in mortality from all cancers by 6%. So some of the numbers, percentages may sound small, but again, as we start to build out all these different dietary elements that we'll talk about in this masterclass, we'll see that there's certainly a cumulative effect. And now factor in some other elements and variables that you may be counseling your patients on around sleep, stress, physical activity, other inputs, environmental toxicity, things of that nature, I think we start to see more of a cumulative effect of a risk reduction. But from this perspective, 30.5 grams a day saw a 14% reduction in all cancer mortality, and then each incremental benefit as well. So I think part of the challenge for some patients when we start to provide these recommendations is, well, it's kind of a big leap to go from, I'm not really taking in much dietary fiber, maybe I'm averaging 10 grams a day, and to have them jump to 30.5 or more, may seem a bit daunting at first. So how do we give incremental benefit there? Having them increase maybe 5 grams a day, 10 grams a day. In the show, there is evidence that even increasing this by 10 grams a day, even if you aren't quite at the 30.5 gram a day recommendation, that you can incrementally benefit from that you can reduce that risk little by little. So dietary fiber intake and colorectal cancer risk, a little bit more specificity here. So this is a recent meta-analysis, which included 20 studies. All 20 studies presented results for high versus low dietary fiber intake and colorectal cancer risk, colorectal adenoma. So results supported the hypothesis that dietary fiber intake is associated inversely with the risk of colorectal cancer. An analysis of these high versus low intake, this dose response model, indicated that the colorectal adenoma risk was reduced by 28% and 9% per 10 gram a day increase, respectively. So patients increasing that 10 gram a day that we saw in the last series of slides related to a decrease in all cancer mortality. When looking directly at these gastrointestinal cancers and colorectal cancer, that 10 gram a day increase was reducing, again, a 28% and then a 9% difference here by having this higher dose. Clearly the higher intake was associated with a higher reduction in risk. So, can make these small incremental changes, 10 grams a day, start to get up to a point where they have this higher level intake overall. And, for the ideal intake of sort of a recommended daily allowance, and the recommended daily allowance of 28 to 30 grams per that last slide, 30.4 grams would be an ideal sort of target to reduce risk of colorectal cancer specifically. And so maybe again, to take a step back, what are some of the mechanisms potentially at play here? We can have a sense of how would dietary fiber reduce colorectal cancer risks? And again, there's clearly an interface between the intake of dietary fiber and the gastrointestinal tract and the small, large intestine, colorectal region. And a couple bullet points here, some areas where we might look to, and maybe where even some of the evidence is actually displayed these mechanistic drivers around reduction in risk of colorectal cancer by the intake of dietary fiber. So certainly short chain fatty acid formation, consumption of dietary fiber results in that dietary fermentation by the healthy gut microbiota, and that increase in these short chain fatty acids, butyrate, propionate, acetate, all of these short chain fatty acids have this anti-inflammatory effect. They induce differentiation, arrest growth, and they cause apoptosis in the gastrointestinal tract. So again, causing these sort of appropriate response and cell death to those cancer-based cells. The other things that the dietary fiber intake may influence is increased stool bulk and reduced stool transit time. So again, reduced interaction between any types of waste products and the actual tissues and cellular structures in the gastrointestinal tract, reduction of secondary bile acid production, and influences in intestinal pH. So again, changing intestinal pH to be more prohibitive towards cancer cell growth and proliferation. And here's a chart. This is from a specific study showing really the importance, again, mechanistically, the importance of dietary residues and dietary fiber and the colonic microbiota in determining colon cancer risk. And in a healthy situation, about 90% of a normal diet is absorbed in the small intestine, and nutrients are distributed to maintain general body health. But the residues, these dietary residues entering the colon, are primarily these complex carbohydrates, these fibrous based compounds that, then again, there may be some bile acids, there may be some protein residues, based on sort of what the dietary composition of a meal is. Of course, increased bile acids in the presence of a higher fat composition of the diet. But really these different residues, and specifically the residues related to dietary fiber, really help to maintain colonic health. They influence the composition of those microbes in the GI tract and influence their metabolic activity. And that metabolic activity, again, is the general metabolic byproduct of those microbes acting upon the fibrous residues, ferment, maintain the mucosal and colonic health, maintain that pH. Again, you've got really, particularly in terms of the short-chain fatty acids, butyrate, which is a preferred energy source for those colonocytes and has an anti-inflammatory. It's been shown to have an anti-neoplastic properties through their actions. So if we have this higher fiber diet, it is associated with a decreased colon cancer risk, whereas dietary intake that are low fiber and higher proportions of fat, protein, tend to lean towards a more pro-inflammatory sort of environment that gets produced. So the chart here really kind of displays this well, that if we have these indigestible residues, if you go down the right side of the chart, we have these fibers, these plant cell walls. They go through fermentation to the short-chain fatty acids, also help with the synthesis of some of these vitamins through the microbes' activity, degradation of some of these polyphenolic compounds as well. And I won't read through the entire bullet point list here, but you can see on the right side column in this bullet pointed list on the yellow box there, that we have cell metabolites that influence a number of different activities that are associated with, again, risk reduction and certainly associated with more of an environment and composition through the gastrointestinal tract that is, again, prohibitive of cancer carcinogenesis. And again, just to go back to some specific studies here, we'll go to this study, which was examining dietary fiber intake in a female cohort, and that the women, the research showed that the women who eat more high fiber foods during adolescence, approximately 28.9 grams a day, and young adulthood, approximately 26.4 grams a day, including vegetables and fruit, may have significantly lower breast cancer risk than those who eat less dietary fiber when young. So looking at even age sort of stratification here to see that when we're at these sort of younger ages, it influences long-term health and development through this anti-proliferative and, again, chemoprotective capacity of here dietary fiber through the fruits and vegetables. So we saw sort of general recommendation one, more fruits and vegetables, more dietary fiber here. So of course the two go hand in hand with fruits and vegetables providing really an excellent source of dietary fiber. So here are some clear, significant changes in this cancer risk of the breast. And some of the hypothesized mechanisms had to do with the fiber's ability to inhibit reabsorption of estrogen. So preventing that sort of enterohepatic estrogen recirculation and recycling into the system. And so with that inhibition of estrogen reabsorption, decreasing circulating levels of estrogen, so getting to a place where, again, the resulting end outcome is a lower breast cancer risk. So just to again, kind of reemphasize these a bit more. So there's the other bullet points here that it is potentially due to this reduction of the recycling of estrogen, decrease also in insulin-like growth factors. That may be here, again, shifting more to the dietary fiber intake, which, of course, if you're increasing dietary fiber intake and reducing dietary fat and protein and having more fiber to balance out blood sugar, less high insulin spikes, more even keel blood sugar levels and blood sugar regulation through the day. And again, secondarily, potentially to that, is the ability for dietary fiber to inhibit some of these activity, really specifically here related to breast cancer, the inhibition of colonic beta-glucuronidase activity. So decreased deconjugation, decrease enterohepatic recycling of estrogen. So really several potential mechanisms here at play that really influence breast cancer risk reduction. And here are some examples, really just to, again, add some practicality to it. Of course, I'm probably familiar with some ideal sources of fiber, but what is apparent is that we would ideally want a nice wide variety of dietary fibers. So we have our soluble fibers, insoluble fibers, fermentable fibers, and resistant starches. And really just highlighted here in the far right column that both the fermentable fibers and resistant starches are those that mainly support the production of the short chain fatty acids that we spoke to, and that seem to have a clear connection to this risk reduction profile. So fermentable fibers include things like the pectins in fruits, pears, apples, guavas, plums, oranges, a number of different fruit fibers. Beta-glucans is a fermentable fiber in oats. Inulin or oligofructose, so inulin forms as a fermentable fiber in food sources like onion, banana, garlic, asparagus, Jerusalem artichoke, chicory, jicama, wheat dextrin, another wheat dextrin, another fermentable fiber, and then resistant starches. So some specific areas here as well. Resistant starches including potato starch and potatoes that have been cooked and cooled rice and legumes, which have some increase in resistant starch content as well. Green unripe bananas or plantains, and then also cashews, all good sources of resistant starch. Okay, so really briefly, just to take a quick pause, we want to try to apply some of this information and have a bit of a reflexive exercise here to look at the content that we've shared so far, that we've discussed, and then based on this evidence, have some application of it and some practical considerations here. So based on the evidence supporting a role for fiber intake in cancer prevention, research determine the current RDA for total fiber intake, then based on the benefits described in the previous slides, draft a one-day sample dietary intake of foods that provide both the total recommended fiber intake as well as a variety of fiber types, detailing the physiological benefits of each type of fiber. So similar to the last slide, consider the different types of fibers. If we talk broadly to patients, they may be including fiber, but again, is it a wide variety and spectrum of other of types of fibers, because they do all have slightly different mechanisms that can come into play here. So we'll take a quick pause with our masterclass here, give you an opportunity to complete the academics to application exercise, and we'll continue in just a moment. So we'll continue on with the general dietary recommendations for cancer prevention. And what we'll go to next is really looking at some of the areas that we would want to limit or avoid or, again, move out of the diet. We've really talked so far about increasing two dietary components, namely fiber and fruit and vegetable consumption. Here we'll go the opposite direction and consider those areas based on the evidence that are associated with a change in cancer risk based on actually removing them from the diet versus increasing those. So the first of which is a reduced intake of processed meats. We want to counsel patients on the idea from a cancer prevention standpoint, whether primary or secondary, that reducing their intake of processed meats will provide benefit, that based on the available evidence from the World Cancer Research Fund and the American Institute for Cancer, that there is convincing, strong evidence that processed meat increases colorectal cancer risk, and that foods preserved by salting, as many processed meats are, exhibit a strong evidence of probable increased stomach cancer risk. So this is one, again, where we can begin to build out more of a dietary intervention for patients. These are sometimes easy and affordable means to go to in terms of the common sort of sandwich for lunch and deli meats and things of that nature that may be part of what is just sort of always been a dietary habit or pattern for a patient. But there is clear, strong evidence here that reducing these specific types of processed meats, not meat generally, but here specifically we're talking about processed meats, that reducing these will decrease the chance of cancer, will reduce the risk overall. And so let's look to the next one. What's another area to potentially moderate or avoid or limit? And that's sugar-sweetened drinks and reducing overall glycemic load. So same thing here. We've got a connection based on some of the evidence that is surrounding this, the World Cancer Research Fund, looking at sugar-sweetened drinks and their association with cancer, and likely through this association with metabolic dysfunction, that high levels of glucose intake, of fructose intake, of sugar-sweetened drinks results in some aberrant glucose metabolism, excess amounts of the substrate that increases insulin growth factor and insulin, high levels of insulin, fasting insulin, and just consistent insulin levels that are spiked or elevated. And then also that these sugar-sweetened drinks are obesogenic. They're associated with an increased incidence of obesity, which is cited as a major risk factor for most cancers. So if we want to look at some things from a general dietary perspective, we could say, again, any things that are obesogenic, any ways that we can improve overall BMI, weight metrics, body composition measures, that those would be beneficial. And certainly, again, these types of sugar-sweetened drinks that are very high caloric concentration, as well as really being, again, not very nutrient dense, but purely sort of high in the sort of glycemic load and sugar glucose concentration would be important to remove. Or even, again, some of this being higher in glucose, but also with the advent and utilization of high fructose corn syrup being high relative fructose concentration in these. So wanting to kind of move these out of the diet, limit these, reduce these overall. The obesogenic factor that kind of ties in here as well is not only that obesity is cited as a major risk factor for most cancers, but that obesogenic really is tying back to this excess adiposity or excess adipose tissue that a patient may have as related to a high intake of these sugar-sweetened drinks. And that with this excess adipose tissue, we have excess production of estrogen. We spoke about that a couple slides ago, trying to reduce that. Adipokines, these adipose tissues that begin to produce their own hormones, they create, again, some various endocrine disrupting kind of signaling in the body, and the direct and indirect effect on other cell growth regulators. So really want to mitigate that, because these high levels of estrogen, these high levels of some of these adipokines have been associated with increased risks of breast, endometrial, ovarian, and some other types of cancers. And finally, another area to consider reducing or avoiding is excess alcohol intake for patients. So again, higher levels of alcohol intake associated with higher levels of risk for cancer. Here we want to try to limit to no more than 2 drinks per day for men and 1 drink per day for women. So a bit of a delineation there, but just limiting intake of excess alcohol. And again, by definition, there may be some cultural pieces here. There may be certainly some other factors to consider. Some patients may not consider that 2 drinks per day is excessive. But again, we just want to get really specific with our recommendations so that we can give very prescriptive nutrition recommendations to patients.